Good morning. Qualified data structures. These are the things that know everything there is to know about an application. This is me, Cliff Collins, BS Computer Science. I'm trying to write Jane, which is to automate the creation of applications. And for qualified data structures, we want to be able to manage automatically all the data structures. So we need all that knowledge that we can get so that we can accomplish that. So one of our primary objectives is to be able to move an application's data structure out of itself with no loss. So that if I move you a data structure, or myself, or I want to split my application across tasks, those data structures cannot lose any information. We want to be able to reorganize a structure for multiple purposes. So if it's sorted or randomized and we want to sort it, should we move that back sorted, and will it make a difference? We cannot make these assumptions. We need to know what we can do with all of our data structures for the intended original purpose. If it's for our purpose, of course, we can do whatever we want to. But if we're trying to cooperate with particular data structures, then even within the application itself, it needs to know. We need to ensure that all information is movable in an automated fashion. Our current technology does not allow us to move anything really without some sort of programming effort, or a lot of programming effort. It's extremely difficult. We need access to all internal structures created by an application. That way the end user needs to be able to see these. We hide them, we program, and we hide these internal structures, and it does us no good. So the process here is to make sure that we have access to them, that they're self-aware, and that we have access to them, so that we can use the application structures for any purpose. And we want to be able to supply logic when required. So if something is encoded or needs translation to a different language, we need all that logic that's required to do that. So in the automation, we want no work by a programmer or user to be able to automate this. And we need immediate results so that we have no programming. And the user can augment knowledge to a data structure. So the whole point here is we need to overcome the isolation of information. Totally. So let's look at some examples. This video is, I wrote an application to look at structures, specifically JavaScript, but it applies to all current compilers, whether it's static or dynamic runtime, compile time structures. We still need to have this capability. So we'll look at them. So in automation of an application, we can make no assumptions, and that's what we're going to look at. Much of what you will see is derived and is therefore assumed. Is it sorted? I can see if it's sorted, but I don't know if it actually has to be, or if it's sparse, or does it only contain employees? Anyway, there's just all this information that we cannot assume. Our current software development technology hard codes all this logic. Therefore, our data structures have no knowledge of itself. It's only hard coded in one location. Does us no good. So we're going to look at how do we get this information in there. And so I have an application that we will look at right now. So hold on and I'll pull it up. Okay, I'm back. Alright, what I did is pulled up collinsoftware.com's website. It's my website. And we're going to go into this memory structure to CG2. And this is the program. Okay, so this is our input source that we can edit. Put some examples out here so you don't have to type them in. We can kind of look at these. So when you change this, it simply changes it down here so you can edit. it's in there as text so that I can display it as text. And anyway, so that this text goes into your structure text, and that gets evaluated, and it becomes your JavaScript structure, whatever it is. In this case, let's go back to our simple example. And these up here, most of this is just simply some references so that I don't have to type them in. Okay. So what we're going to do is we're going to transform this array of 1, 2 into CG2. CG2 is my Common Ground 2000. I wrote that thing in about 1992 or something for a conference. I'll include JSON so we can see what JSON produces and how well that does what we want it to do. This first line just simply introduces this as a CG2 file. These are comments, and basically I'm saying here are the keys when you just go through a loop of keys, and this is how you get them. And then these are all keys, which has your index into the array, which is 0 and 1, and then length. And this is how you get all those keys. So the properties for here, I've defined a structure, and it simply says here's the name that I created, and then we're dealing with an array structure. Comes from JavaScript, then it's unnested. We'll show those later. And then here's the array. It says length is 2, and that's this here. So length is a number, which is 2, aka it's actually next available index. It's not the length, it's simply the next available index. And then here are the values, which is numbers. So I put parentheses, you can use any format you want, but these are the two values. So the first value is index 0, second index is 1. And then this gives us properties saying that length is not configurable, means I can't change this particular structure, and that it's not enumerable, meaning that it's hidden when I ask for keys. They use false. I didn't want properties coming out for every element, just those where properties were set to be false, which is their convention. So I declared it as a Boolean, but by default I set the values to be true, which is how they produced it. So I don't have to put up properties out there for everything. So, and then this is how JSON does it. It says it took that and put it out as the same as a JavaScript array. Show you that next available index is really what length is, and so we'll do that. So we'll look at this structure, and we'll say, let's just put 3 here. Okay, so we put 3 there, and we run this. So now our keys are 0, 1, and 3. 2, we have no index for 2, so it's actually, we actually only have 3 values, not 4. So our input structure looks like this. JSON does 1, 2, null, but unfortunately null is not correct. It's undefined, and there's a huge difference between undefined and null. It's used for 2 different purposes in programming, so I can't trust that. So here, since it's a sparse array, which I told it here, and said that this is a sparse array, and so that I need to put the name and the value out here. So name is 0, or my key, if you will, is 0, 1, and 3. Okay. So we can prove this. This is why we can't trust. We need a better method to create software. So here, oops, what happened? Okay, so here, okay, length is really next available index. I can just tell it that my next available index is 20. The array doesn't change. So my keys are 0 and 1. It still has 2 values. My next available index is 20, but unfortunately JSON thinks that length is length, but it's not. So they come in here and put nulls in, which there's only two values here, 0 and 1. So I push 3, I set my length, so our keys are now 0, 1, and 20. Okay, so now, unfortunately, if I took the JSON, now they might go in and say null means undefined. Unfortunately, it does not. Okay, so I can come in here and say null, and so 2 is in there as null, which means something to me, which means that I have no value for it. Undefined means I don't know. Null means yes, I do know, but I don't have a value for the second one. And that's the difference in programming. So we look at other structures. Here's one, kind of looking at what JSON does. So here's an array. A and B are arrays. I put these two arrays in here. And I did this so that I can, A is an array, I can assign it a non-numeric. Arrays and objects are identical. It's just their use and what the index is and then what subroutines are attached. But other than that, they're identical. It's just a name value table. Here's a name, here's a value, here's a name, here's a value. And so that's what JavaScript is built on, and most structures. Anyway, so I stuck name in there just so I can have a reference. So if I run this, okay, so I used A here. I said this is array A and this is array B. What I'm trying to do is I'm trying to get our internal information structure understandable and readable, and do it in a way that it's editable also. So if I wanted to come in here and change this structure for any reason, I could just edit it and then reload it. Basically what I'm doing is our objects in memory have to be able to be moved out and moved back in and produce the same identical memory structure. If we look at JSON, it created 7 arrays, but actually there's only 5 because it's A, B, and then B, A. And these are still identical arrays. So this is one array. So A and B are, so we have 2 arrays there. This one's one array. That's 3, 4, and 5. So we have 5 arrays, not 7. However, JSON says there's 7. They repeat the same array, which is different from memory. Okay, so we have to understand that we're after identical structures, and if we can't rely on the information structures being identical, then we cannot share them. We cannot work on the same data structures. And we have to all understand their basic fundamental structure, retain that, and be able to work on these structures in a shared manner. So I can move this to you, you can make changes to it, send it back to me, and I wouldn't even know it. You know, it's all, so this way I can split my program across multiple machines, and I can rely on the structures and not make assumptions. So JSON made an assumption. Are we just after the values? Or are we after the structure? I'm after the structure. JSON only did values. And we can see that further in oh, here's one. Person is a function. Okay, here's person down here. This is my class. I did it simple. I didn't use the class declarative. The structure. So here's the array, has a number, which is the length of the array. And then I have to put name, type, and value because it's sparse. Okay, in this particular case, it was sparse. I did not put I put a true, undefined, 2, 3, 4, and a function person. And so that's what I got. So I have 6 values. Our next available, sorry, I think it's linked. It's not linked. I got to remember that. It's the next available number. So I really only have 5 values, not 6. So we need to actually put both. How many are there, and then what's the next available index? I can't program without knowing this. I can go in and look at it, and what we do is we program so that, oh, I understand that 6 is linked, but it's really not linked. So it's up to me to remember that. I cannot do that. I have to go in here, and I really need to define, and that's what this program is for, so I can see, do I understand, does the computer understand what I understand? And then we can automate our programs. We can't do it when we don't see the values and know the values, and humans pick arbitrary things. Like originally when JavaScript, they did not do sparse arrays, so they picked linked. That gets in the conventions. Now linked is not really what it is, so I haven't chased down there if this is true or not, but programming for 50 years or so, I kind of know what people are going to do. Okay, so names get out there, and then nobody wants to change them, because then you have to change it in 20 billion other places. So I have name 0, Boolean true, index 2 is number 2, index 3 is number 3, index 4 is number 4, index 5 is a function person. Okay. Okay. Jason said, I have a function, but I'm not going to give it to you. I'm just going to tell you that value is null. I don't know what it is. I mean, if I just read this, I have no idea what these values are. I don't know what goes in them. I don't know what 2 is or anything else. And me, I went ahead and created a define statement. Okay, the CG2 introduces CG2 files. These are comments. These are declaration statements for, it's basically a CSV, comma separated values file. So value, comma, 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 and then terminated by a semicolon, which says I can cross multiple lines for one record, which is very convenient. And so it's tagged. So it's a tagged CSV. So structure is this. And now I have an array, but I want to tag it as a unique identifier. So I put the unique identifier here. So array 0 through this second value here knows that it's an array that it's dealing with, and calls the appropriate function to load an array. And that, I won't get into that, but the system does all this for us. We don't have to do any of this. This is the automatic loading and unloading of our information structures. So a lot of them we don't get in our compilers. We don't get our call stack or any of that. We need that so that we can jump around and do what we want to do. So the point here is we got to take memory, put it out to text so we can move it somewhere and load it, and understand the same thing that the original program did. We need to get our description of our data out of hard-coded source. The source code says, oh, this is an integer, but the data itself doesn't know that. So if I store that 3 off as in a file somewhere, I don't know if that's a number 3. I don't know if it's feet. I don't know if it's the number of dogs I have, or my age. We don't know any of that, so we have to get all this information in here. And that's what this format's going to do, is allow me to put all that information in, load it in, keep it with the information, and then our information is not locked up in somebody else's source code, because only one piece of source code can ever reliably create and manage information if it's only in source code. We're going to get it out of source code, put it into a structure. So we say we can't trust JSON to do it doesn't really tell us anything, and it starts deleting information. I stuck here our script, which is simply a script tag that gives you a name of it and then the value. and then I use this tilde to uniquely tag the content. I stuck in, generally you just use 2 of them. And if it finds 2 of them in your source code, it tries a 1. If it finds that, it does 2, and so on. So it will uniquely tag your content, so it can contain, you know, I mean, it's gonna try until it runs out of numbers. So I don't know if there's, you know, anyway, and it doesn't have to be a number. It can be it can be up to, I think, like 30 characters in there. That, you know, if you want to put your name in there, that's fine. I want to be able to move scripts around, because person up here, if I send this off to somebody and says, well, yeah, you said person, but what's that? If I don't have the scripts, it does me no good. All right, so we'll look at another example. I'm just trying to demonstrate some of the things that we do. Rachel. Okay, Rachel is a person. So Rachel is a new person. Persons is a plural of person. My little container. I pass it, so in my little example down here, I wanted to force a circular reference. So this.persons equals persons. When I run this, JSON, if I try to stringify it, it says circular reference cannot do, which does us no good. But we have many circular references. I mean, you know, I'm down in person. I'd like to know my container or who owns me, and so these are just very fundamental programming requirements, and yet we have no way to move those. So I said, look, let's just tag them, do what we do in memory, and move on. So here's our person. When I say nested and unnested, I simply mean that I pull out the properties and I kind of structure this so you can see what owns what. That's not very easy to read. It is if you need it. And that's the whole point here. I'm trying to get it so that we can get our information out. We want all of our substructures, and so it's got to be completely automated. So Jason says, I'm not even going to try. I'm not even going to do null for you on a circular reference. But here I did. So I can resolve these, build the same identical structure that I had started with, which is, there's a lot of, I call this qualified data structures, because we may not want properties. We may not want links to get these structures out. I spent 2 months trying to figure out the best way, and then I just said, look, I'm going to do it simple. Could have done this in 10 minutes, but I spent 2 months trying 10 different ways to, okay, these are nested structures. This array is within that array, and so on and so on. So, but when I run this, I actually separate them all out. So they're individual arrays, and then 2, and here's array 2 again, but they're only interested in the values. I'm not, if I'm writing program, I'm really interested in the structure, not in the, you know, the values are going to be there, and we're going to get the values out. It's just we also need to retain the structure. We need to be able to do this automatically. And so all the structures that we have in our programs, our applications, I want those internal structures. We never supply them to the user. I said we need to supply them to the user so they can validate their own information. I'm sorry, but this is their information. It's not the vendors like Oracle or anybody else that says, oh, I will give you what I want to give you, and I will perform the task that I want to perform. But this is your information. This array is your structure. That's what you created. That's what you own this. And so this whole thing is all the internal structures, even the program that's generating it has internal structures. I want to be able to see that. So if I'm running a compiler and I want the call stack, I want that. I want to be able to see that and see what values out there, and then reference those values. So if I want to get, the name of the function that called the function, and then how many times it was called, and all that information that's available to us, then that should be available to the end user as well. So that's what I'm going after. Sorry I'm taking so long on this, but I think it's important to understand we have to have access to our information, and we have to be able to get it out reliably and then back in. So this information is going to go out, be stored on disk somewhere, and then loaded back in. And it has to be automatic. So there's no programming involved here. So we're getting rid of the programmer because we don't. If we reliably have a way to do this, right now we have no way of doing it. We create a structure and then we have some little function that says, oh, I'll kind of give you a representation of it. But that's not the true representation. So, all right. So that's our demo on qualified data structures. Once I get the compiler, I'll put together, CliffCode's my compiler, company name and compiler. And so it will have all of this automatic. Most of this you'll never see, unless you want to, of course. Oh, well, how many structures do you have? And it'll list them out in a CG2, and then that can also be pumped over to a visualization tool, because a visualization tool can read this just as well as me. So this is all defined to be readable and understandable by the human and also by the computer. So information is no longer locked up into single application source code. There is no source code here unless you want it to be here. Okay, well, thank you and have a great day. Bye now.